And we are live. Okay. Now,
Interesting.
okay. Okay, so basically for that, we're going to click on our gender group and go to transform and automatic recode. Is that?
Yeah, I guess so. I don't know. I'm just going through what's in the textbook now with this data file. I don't know if I necessarily need to, but
Okay.
it seems I don't know. Excel has a similar function. It's called COUNTIF,
Okay.
or I guess an if statement. And I just use Excel a lot with my work, so this I don't know. It's kind of cool to see it in another program, I guess.
Add new name. Uh-huh.
Just
Okay.
gives me ones and twos.
Okay, so then we're going to go through our regular thing again, right? We're going to
The
analyze.
mhm.
Trends, independent samples t-test.
I don't think that we've used. Have we used the independent sample t-test?
We haven't yet, but that's what the book says to use.
Okay then. Book. Let's do this.
Um,
Oh, let me make sure I'm doing this right. So your group is the grouping variable. Okay, makes sense. And then your test variable is what you're testing. Okay. So in this case, we would want to do their wage.
so that's our test variable. Grouping variable is gender.
If gender works, then yes. Either
Define
that
group
or
1 is
we
1, group 2 is 2.
use. If
Okay.
gender doesn't work, then you can use that new column that you just made, and that should also work.
Well, that didn't work.
Okay. All right. So did you just say that it didn't work when you tried
It didn't
using
work on
gender?
my end.
Huh?
It did not work on my end.
Okay. Did
Let
you?
me try this again. Automatic recode, gender code. Okay. 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 We go to analyze, compare means,
Mm-hmm.
and go to independent samples t-test. Test variables is wage. Grouping variables is gender.
Now, are you using gender or gender code?
Oh, that is probably my I goofed.
Did the new column, did you call it gender code?
Yes.
Okay. Because I use that and that works, so I'm wondering if maybe that's what it was?
That's probably what I did. There we go.
Nice.
So did you get a mean on the females of 9.75
Yep.
and the males 11.94?
Mm-hmm. I did.
Well, that worked. Yay.
We like it
Okay.
when it works.
What?
I think we like it when it works.
Okay. And then
Okay.
what's our standard deviations?
Oh,
Whoa. Standard deviation on female was only 3.169, but male was 10.491.
so it seems, yeah.
Okay.
So let's look at the homework thing. So
Okay.
our research question is if men and women are paid the same, right?
Yeah.
Okay.
So your null hypothesis is going to be U1 equals U2, and your alternative hypothesis is U1 does not equal U2. Is that correct?
My understanding, yeah. Because we're not given anything that says that it would be greater than or less than.
Yeah. Okay. So that's part B, right? So we're on to 2.
Yep.
Describe the data collection procedures.
Well, our professor gathered the data through a survey.
Okay. Sounds good to me. Uh, describe in a short paragraph, use summary statistics to describe the data. Well, we already found our X's for males and females, and we found our standard deviation for males and females. Do we need to find anything else?
I don't know.
Oh, probably our N. Shouldn't we put our N in?
Oh, that would be good, yeah.
Um, do we put like the degrees of freedom and the T and all that in there too, or just
I don't think we do here because it asks for it later.
okay?
Um, I'm not 100% sure though.
Let's see. Let me. Oh, if you go to the answer key, it just asks for the x's for each, the standard deviation, and the number for each,
Okay.
and the histograms, which we have on our thing.
I'm really, really glad that he doesn't want us to turn these in each time.
Yeah. Okay, what type of hypothesis test is appropriate? That one I'm not sure on. Let me see.
Well, we just do the two means that are independent? Or am I thinking of something different?
See, it says independent samples hypothesis test.
Okay.
Okay. Are the requirements meant for this test? Well, your sample size is fairly large. I mean, that's what, 183 students. So I would say that you can assume normality, right?
Yes, but I don't think it was a simple random sample.
Right, because it would be,
Convenient sampling.
yeah.
So, would we say no then? It's
I
not?
would say no because it's not a simple random.
Okay. No, I agree. Does the key agree?
Uh,
I can check.
Key says the sample size is large for each sample, so we can assume normality, but it was not a simple random sample. So yeah, both things are things we brought up. What's the test statistic?
And
Now,
that's going to be our T-score?
what?
Is that going to be our T-score?
Well, but you have two t-scores. That's why I don't understand which t-score we're supposed to use. Equal variance assumed. So the t-score for that is negative 1.889. Equal variance not assumed is 1.836.
So,
I guess since what we're testing, you'd go with the alternative hypothesis because it's what's not assumed, right?
well, no, don't we go with what's assumed first? Because we assume that the null hypothesis is true until we can prove otherwise.
Yeah. Well, the answer this has is the 1.836.
And
According to
that's the variance not assumed.
yeah.
Yeah.
That's also the degrees of freedom that it takes is 98.263. So I'm guessing that's right.
Okay, let me just look at the reading real fast, see if we can explain that.
Okay.
All it says in the textbook is that in this course, we will always conduct analysis using equal variance not assumed.
Oh, okay.
Yep, I guess so.
Okay. So our p-score is 0.069 and our alpha is 0.05, correct?
I don't remember actually taking note of the alpha.
Okay. Well, because we figured at a 95% confidence interval, I thought the alpha was 5%. Or am I thinking wrong?
Let's assume that,
Okay.
because it doesn't say in what we have, and that reasoning makes sense.
Okay, so we're going to go with that then? Our
I think
alpha
so.
is 5? So the p-value is 0.069 and our alpha is 0.05. So if that's the case, then we would fail to reject, right?
P-value. Great. Yes.
Okay, present your conclusions in the form of an English statement. Statistically, there's no difference in the wages, right? Between male and female BYU Idaho students?
Because we failed to reject our null hypothesis.
Right.
So yeah.
Okay.
I didn't do what I said I was going to do and hang that places.
Okay. Oh, rather than test an hypothesis, now say you just wanted to estimate the difference between female and male wages at the 95% confidence level. Create a confidence interval to estimate the difference.
Well, don't we already have the confidence level?
I think
just on the far right side.
Do we in here?
Hi, Mommy.
Let's see. Confidence level. Confidence interval of the difference? Is that what you're talking about?
Yeah. Does that sound like the right thing?
Negative 4.528. Okay. This is odd.
Why?
Because their answer is the same as what we have, but reversed, if that makes sense. Like, lower on this is negative 4.528, and upper is 0.176. And the answer they have is negative 0.176 lower and an upper of 4.528.
Hey, friends of scouting.
Do you?
You're gonna check. Should be cash. 20.
Just a second, Bernie.
Okay.
You're just doing if you're a cash.
Okay, so it's opposite. I remember there being something about it in the instructions.
Oh. Yeah, it says you use a confidence level of the opposite sign. When defining the confidence interval in SPSS, if the two groups are reversed, the means are subtracted in the opposite order. This results in a confidence interval with the opposite sign. We assign the gen group as the first group and the dev group as the second. We would get a confidence interval of, then they swap their signs from the previous example. So that's probably what it was.
Is that step 4?
Let me see, what was I? Step 5. Step 4 tells you how to get the original confidence,
Okay.
and then step 5 tells us how to swap them. Then,
Okay.
do we want to try the homework? The quiz or whatever?
Yeah. Let's do it. I was just trying to understand why you would do it like that. Sorry, with the confidence intervals.
That's fine. Okay. 16 again. Yay. Isn't 3 both A and B?
You're gonna have to give me a second. It kicked me out.
Oh, that's fine.
It really kicked me out this time.
Okay.
Okay, got there. Yes, 3 A and B.
Okay.
And then 4 would be a T-score.
Yeah, that's what I was just looking. Yes, T-score. Let's go with the F statistic. I don't know what that is, but hey.
That's this statistic to see how many people fail a class.
5 would be B, right? Knowing which subjects are in group 1 tells you nothing about which subjects will be in group 2.
Mm-hmm.
Okay. So... Oops. Get a cut and paste here going.
Sometimes it's really easy to copy and paste things. Other times it's really difficult.
So how would we enter this into the thing?
Did you put them in as 2 columns?
Yes. Do we put them in as we put them in as 2, right?
That is a wonderful question. I don't really think so.
Okay. So we can put them in as 1, but then we'd still have to separate out Rexburg and Idaho Falls by putting that in like variable 2 spot, right?
Right. And you can just put 1s from 1 to 20, and then 2s from 21 to 40.
Okay.
Or, I mean, just some way to categorize them.
Let's see if I can get this. Okay. Okay. So, degrees of freedom, right?
Mm-hmm.
I got 37.996.
I got the same.
Okay.
And then this sample standard deviation for list 2, I got 288.597.
Okay, I got a mean of 288.597 and standard deviation of 206.637.
Oh, what did you say it was?
I got a standard deviation of 206.637.
Okay, yeah, so did I. Just put down the wrong thing. And then a test statistic of negative 0.434.
Yes.
Okay, now here's, with number 9, the p-value, would we want to take half of what our sig is on this one?
I would say yes, because it's a one-sided.
Okay. And
And
so
we would
fail to
reject, right? What?
Would we fail to reject the null?
Oh, yes, we would fail to reject because it's larger.
Okay.
Oh, come on.
And 11 would be the same, because we would still be greater than our alpha.
If I can get there, it's frozen at the moment. I don't know. Yeah, you would fail because that if you're doing that, then it would be twice as big. It would be the 0.666, right?
Mm-hmm.
Okay. Okay, so for 12, it would just be U1 does not equal U2, right?
I actually haven't looked yet. I was just putting the data in.
Oh,
Let me look at it. Number 12. Yeah. Agreed. It would just be is not equal to.
okay. Mm. Okay, so the test statistic is 0.845.
That's what I got. And then for the p-value, I got 0.410.
Yes, 0.410.
Okay. And then our alpha was 0.05.
Right, so we would fail to reject.
Yes.
Okay. Okay, is this one where we would reverse it, I guess, the confidence levels? So it'd be negative 5.137?
I think so, yeah.
And positive 2.204?
I think so.
Okay. Should we submit it?
Yes, we should. Submit. Yes. 94.
Oh.
What?
What did we mess up?
The last one.
That's one I'm going to have to figure out about when to... I don't know.
Yeah.
Alrighty then.
Yeah, I don't know how to I don't understand why you would do that.
I don't either.
Whatever. We'll figure it out eventually. He probably will say something about it in one of his videos.
Yeah, I'll probably watch the videos. So. Alrighty, well, you have a good weekend.
You too.
We'll
Enjoy
see.
yourself, but don't have too much fun.
Alright, we'll see you next week.
All right, thanks, Bernie.